This is problem 14.4.27, and here we have a pharmaceutical company that is investigating the relationship between men's ages and their LDL cholesterol. So we've got a data set of 7 randomly selected subjects, and we are asked to construct a 95% prediction interval to estimate the cholesterol level of a 36-year-old man. So I have the data information over here already into Excel. And in order to get a prediction interval, I'm going to need to go to XLStat. So I'm going to go into the modeling data and linear regression. And here is where we will input our information as usual. So the dependent variable information is already input into the box here. And same with our independent variable information, it's already been pre-filled. And I want the data output to go into a separate sheet. And if I look into the options menu, we've got a default 95% confidence interval. And output is going to be the same, just using analysis of variance. And I have no charts selected to show up in the output. So the only thing that's really different from what we've done with the previous problems is that we are going to utilize this prediction menu here. And this is where we'll input our x variable, in this case would be 36, to run with the output. So here we need to actually utilize a cell reference to get that value into the box. If I were just to input 36 in this box, then ultimately XLStat is going to give us a error message. So I need to utilize the cell reference, which is why I just manually typed in 36 into this box here in the spreadsheet before starting the regression in XLStat. So I just click OK. The output's going to go into a separate sheet. And it's going to provide all the same stuff that we're used to getting, the R squared, for example, the F statistic, and the p-value. We have our coefficients, which help us to generate the linear regression equation here. But we also have now this additional table, which is the predictions output for the x equals 36 value. So x, again, 36, we have a predicted value of when x 36. So when we have a 36-year-old male, we predict that the cholesterol value would be 174.71. So how do we get that value? Well, we just plug 36 into the regression equation. So we have a slope of 1.797. We multiply that times the x value of 36, and then we add the intercept value of 110 to that. So that gives us our 174.71. But it also gives us a couple of other things in this table that are very useful. One is the confidence interval here, and then we also have the prediction interval, which is what this particular question is asking about. So the confidence interval, what this is saying is that we're 95% confident that the average cholesterol for all 36-year-old men would be 174.71. And with the prediction interval, this is saying that we are 95% confident that a 36-year-old man would have a cholesterol of 174.71. So again, the big difference is the average cholesterol would be 174 versus the cholesterol for a 36-year-old would be 174. So you'll notice one more thing is that the interval range is much larger for prediction interval, just because we are being more precise and specific about applying it to a single value, as opposed to the confidence interval having a more narrow range, just because this is based off of an average value. Notice also that when we went past the initial information of the output, including the ANOVA table, that the p-value of our model is high. So our alpha is 0.05, and our p-value is greater than that, it's 0.188. So what this is saying is that our model is really not a good one. So if we were to be doing a hypothesis test, our null would be that age is not a good predictor of LDL cholesterol in men. And being that we have a p-value that's greater than our alpha, we're not able to reject that null. We have to assume that the null in this case is correct, just again based on our sample of 7 males scores. So looking further down into the model parameters here, we have our intercept and we've got our independent variable of age. And scrolling over here, we can see the p-value. This is going to match the model p-value just because there's only one independent variable. But in a multiple regression, we have more than one independent variable. We would be able to evaluate the p-values of each one and see which are significant in the model and which are insignificant. So based off of what we have here, just based again on our sample, we could say that age is not a significant predictor of LDL cholesterol in men.